Hi, this is Ross from Virsae. This video concerns root cause analysis for IP telephony issues. I say IP telephony issues as opposed to VoIP issues because here at Virsae we believe in managing the entire UC ecosystem. So much more than just voice quality or VoIP monitoring. But also all of the critical signaling channels that run between the various components in a UC ecosystem. So VSM mines a tremendous amount of data about the whole environment, the whole ecosystem, not just voice quality. So a good example we're going to look into was an incident at a customer recently. They were complaining of not only voice quality issues, but also IP phones being lethargic, so they weren't responding to button pushes very quickly, drop calls on media gateways, and this caused had a reasonable impact on business for this customer, and they're looking for a root cause analysis after the fact to find out what went wrong, because the problem spontaneously cleared itself, and of course they don't want to repeat. So using the VSM toolset, if we start up here with Availability Manager and go into the report section and look at alarms, we're going to look for any alarms that occurred in the offending time period, which was November 23rd, 24th, and this report will show both the resolved and unresolved alarms that occurred in that time period. I like to drop this out to Excel because it makes it easier to sort and filter and view that way. So I'll just under the view I'll freeze the top pane, the top row, so that we can see what the titles of the columns are. Do an auto fit there for the text so we can see the whole thing, and sort this based on the alarm name. I'll group all the alarms together. So what I'm looking for here, and is standing out there, is we're getting H248 transaction timeouts. So what that means for this customer is that they've had media gateways that are not happy with their connection back to the media gateway controller. And if we scroll across the page a little here, we'll see that affected multiple media gateways. So during that period of November 23-24, we had 3 media gateways in there that were complaining of connectivity issues to their media gateway controller. So of course they could have been sharing the same media gateway controller. We don't know at this point, so we'll keep an open mind about that. But we're definitely seeing an issue there as far as those media gateways are concerned. So if we want to dig a little bit further into that, staying with Availability Manager, in the report section, we'll go into the media gateway timeout report. So what this is going to show us, the scale of the problem and also the timing, so we can see if those 3 media gateways were experiencing issues at the same time. So if I go through here and I use the control button to select the media gateways of concern. You can use the shift if you want to do a whole group, but just using control to pick out the ones that I know had issues. So what I'm hoping to see here is not only the extent of the problem, but the timing. Did these H248 timeout messages happen about the same time? So there for media gateway 22, we're looking at it about 3 in the morning on the 24th. Media gateway 71, same sort of thing, around between 11 PM and 2 AM there, media gateway timeouts. Again, 11 o'clock midnight for media gateway 101, and media gateway 46 a little bit earlier in the evening, around about 4 PM. So what we're seeing there is media gateways, particularly this one here, getting a lot of H248 timeout messages around the time of the outage that the customers reported through. So sticking with the signaling side, If we have a look at the IPSIs, so again, Availability Manager, Reports, and into the IPSI peg count. The IPSIs in the VIA environments are really intolerant of poor network performance. So if there was any network issues that were on the control network portion, so in other words, between the communication manager and the port networks, if there was any issues with any network connection in there, we'll start to see that the IPSIs were having missed heartbeats and were registering peg counts. Now this customer, the first port network is in the same room as the call server, so same room as communication manager, so just a LAN connection, and so we're seeing nothing there. So there was no nothing showing up on that portion of the control network. But when we get out to port network 2, which is out in Penrose, that's connected via the metropolitan area network, we can see in that same time frame, similar time frames to the media gateways, we're seeing missed heartbeats and network outages there between 1 and 3 seconds, the yellow and green. So that's starting to line up. We look at port network 3, which is in Hamilton. Same sort of thing, around 2 AM, missed heartbeats, network outages between 1 and 3 seconds. So we're starting to see a pattern emerge here where some of the customers' media gateways were complaining about their connections to the media gateway controller and some of the port networks. So straight away we're ruling out a single component, so it's not a single component as far as the port network goes. It can't be the call server, and it can't be media gateway controller, of course, because they sit inside the port networks, and in particular the majority of them at this customer sit in port network 1. Not all of them, but the majority. So it's starting to look like a network issue, but we'll keep our minds open at this point. If we jump into Capacity Manager and have a look at the H248 signalling report there as far as capacity goes, this is going to show us which media gateway controllers were, or what the loading on the media gateway controllers was. And what we see typically is if the H248 timeout messages are bad enough, you'll start to see the media gateways that are concerned, they'll start looking at their media gateway controller list and they'll find alternate media gateway controllers off that list. So you can see here this yellow one here, which is 02B04. It had 2 media gateways registered to it, and they found alternate media gateway controllers. You can see around this same time frame in that transition, midnight, early hours of the morning on the 24th, that transition there, media gateways finding alternate media gateway controllers. And that would indicate that the network is intact. It's just become fragmented. So some network segments are out of reach, and others are still reachable. So the media gateways have found alternate gatekeepers at that point there. In a very similar fashion, we can look at the IP phones because they work in a very similar fashion. In this case, they use H323 as opposed to H248. And we've got a report for that in Capacity Manager as well. So I'm picking if this was a network problem, you'd also get a number of IP phones that do the same thing. They'll have trouble talking to their controllers. So they'll go off, look at their list, and they'll find alternate controllers. So I'm picking we'll see exactly the same thing here, as we'll see IP phones that come off one lot of CLANs, so one lot of gatekeepers, and find another. And that's what we're seeing around that 11 o'clock, 12 o'clock midnight period. There's a dip here for these gatekeepers, and the phones are finding alternate gatekeepers up here. You can see the respective lift. So as a once over lightly, we've got plenty of evidence there within VSM saying, hey, that this was not an Avaya UC technology issue because there is no single point of failure. In fact, we've got multiple devices. We've got multiple IP phones, multiple media gateways, and multiple port networks, all complaining about network connectivity at the same time. So plenty of evidence there to start looking, pointing things towards the network. If we really want to get into some depth, we can start looking at the configuration. So if we pull the CMDB, so VSM has that ability for us to go back in time and look at the configuration in the past. So while this is reasonably static, we can go back and look, so it's probably prudent to do so. And we'll look at how things were configured on that 23rd, 24th time period. And what I'm looking to do here is look for a pattern in the around the IP network regions. So if we pull this out, pull out the CMDB, I'll do the same thing, put it into Excel so we can filter and sort. Makes it a bit easier. So I pull that down to my workstation now. Again, I'll freeze that top row. So we've got the column titles there. And the column we're interested in here is the item column. So let's expand that out a little bit so we can see the text there. And again, if we do a sort on this so that all of the components that we are interested in looking at are all grouped together. So I'll sort that based on item. And in this column, we're going to start looking for those three key elements. So I'll start off by looking for the IPSEs. So IP server interface, that'll be enough of a qualifier for us there. So IP server interface. So we can see that the IPSEs are in port network 1, 9 and IP network region 1, 9 and 70. So IP network regions 1, 9 and 70 we're looking at there, and that's port networks 1, 2 and 3, as you can see. So there's our port networks. If we look next at the control LANs, so these guys are acting as the media gateway controllers, or the gatekeepers, some people might refer to them as. And we can see the control LANs are sitting inside those port networks. So as you'd expect, they're also in IP network region 1, 9 and 70. So the final item we're looking at here is the media gateways. So let's have a look for the media gateways and see how they're configured in terms of the network regions. So this customer seems to have them nicely lined up. We were looking at media gateway 22. It's in network region 22, as we can see. Media gateway 46 and 71. Network regions 46, 71 respectively, and 101 there. So what we're interested in is any evidence we can find of connectivity issues between 1, 9 and 70 collectively, trying to talk to network region 22, 46, 71 and 101. So from there we'll look at the other aspect of configuration and go to the as-built schematics. So Virsae builds these as-built schematics on a weekly basis. So if we go back, we can find around November 23rd, here we go, network region design for the 23rd. Again, this is pretty static, but because we can go back in time using Virsae Service Management, it's prudent to do so. So here's our network region schematic as of the 23rd, 24th of November. I'll just zoom in a bit here. So if I'll grab my pen. Now what we're starting to look at is for commonality and connectivity between network region 9, which we've got sitting up there, network region 1, where the media gateway controllers were, and network region 70, which I guess is going to be on another page. But we do have network region 22 also on this diagram, and network region 101, which is another one of the another one of the sites of concern. So immediately looking at this diagram, if we simply follow these lines in here, we're starting to see that certainly a common factor to all of these network regions is 239, sitting right there in the middle. So this is potentially where that problem lies. If we just come across and clear that off, have a look at the second page of this, so we cover off the other remaining areas of interest to us. So I grab my pen again. Interestingly enough here, we can see network region 70, which is one of our port networks. Network region 46 appearing up here. Those are the other two ones we're looking at. The commonality with these guys here, again, I'm seeing 239 over here, and of course they connect via 240. So both these guys up here, down here, up here, across there. Network region 71, similar, across on that same connection and into 239. So hopefully what we can see through this is that Auckland Metropolitan Area Network 239 is the one thing that is in common to all of these, all of the connectivity between the various network regions. So I'm starting to feel that the most likely cause of this problem is a network issue inside the Auckland Metropolitan Area Network in 239 there. Now, of course, if your network region design lines nicely up with the customer's LAN WAN topology, we can start to get quite confident about that. So, you know, another good reason to make sure this configuration is aligned nicely. So staying with that theory that this is going to be a problem with the network, if we jump into Availability Manager and in the Syslog area, we'll browse some Syslog files. Because what the Avaya UC environment does, and it's quite nice, does this quite nicely, is when we start to get problems on the network, is it starts to run pings and trace routes, and it records the result of those trace routes in Syslog, which of course VSM is picking up. So I go to have a look at a Syslog, we're going to look for something around the date and time of the issue. So this is 2015 November, this is the 11th, 23rd, 10:55. I'll grab this one down and have a look at this Syslog. So it's now to come down onto my local workstation. Open up the Syslog, we're going to look for any events that are related to trace routes. So what we're looking for in this log, if we do a search or a find, is an IP event, IP EVT, and find next. So let's expand this out a little. So what we're starting to see here is that there's been an IP event and the IPSI is starting to run a trace route. And we can see the various hops there. So it's trying to ping from 10.60.14.130 across here. It's trying to ping to 10.60.34.4. And here's the hops coming through here. And if I keep searching in a downward direction, we can see it gets as far as hop 5 there. So you got hop 1, 2, 3, 4, 5. And here we go on hop 6. We're starting to see a problem. So on hop 6, there is no response. So we're getting this timeout here. So very clearly, very concisely, we can go back to the network guys now with some pretty solid evidence that there was a problem with the Auckland Metropolitan Area Network. And for example, if we're running a trace route from 10.60.14.130 up here through to 10.60.34.4, we weren't getting past, we're getting as far as hop 5, so we're getting as far as 172.18.14.220, and from then on there was no response. So we can see that there's a hole in the network between these 2 points. So very, very concise. And we can go back to the, as I say, go back to the data networking guys or the management, whoever's looking into this problem, trying to find a root cause analysis, and we can say very clearly, very concisely, using data from VSM, that there was a problem on the IP network in the metropolitan area network, and it was between those 2 respective IP addresses and the trace route. So I hope that's been of some use to you. You can see that that VSM obviously has a huge amount of data available, picked up in the logs for helping with just this type of situation. Cheers.